What I'd like to do today is talk about the way that Illumina is approaching delivering these genomic solutions to our customers and to the world to unlock the power of the genome. I want to start, though, by just taking a step back and getting a few definitions straight. And I don't think I have to dwell on this too much because of the background of the people in this room. But when we talk about genomics, what we're talking about really is the branch of molecular biology which studies the structure and function and evolution and the mapping of our genomes, right? Which is our DNA. And when you're doing sequencing, you're essentially determining what the sequence of those key bases are, those codes are in that DNA. And, you know, I think it's fair to say that the Human Genome Project really put DNA sequencing and the understanding and a better understanding of what the human genome could potentially offer on the map. And when you think back, it was back in 2003, I believe, when that project was completed. That first human genome took over a decade to deliver and cost $3 billion. And when you think about where we are today, where we can deliver a human genome at 30x coverage in less than 24 hours for just about $1,000, I think it's an inspirational story, and it forebodes well for where we can take this technology and what it's going to enable. But you know, as we learned from the last speaker, DNA is just but one factor in what makes us who we are and life what it is. It is important to understand, though, that despite the fact that there are multiple factors, you can understand a lot by understanding more about your genome. So, for instance, we know that by some of the work that we see from our partners in pharma, that we can start to inform better selection of chemotherapy agents by understanding the molecular profile of the tumors that people have been diagnosed with. We know from evidence that we are able to understand more about the genetic maladies that people may be predisposed to by understanding what their genetic background is. We know that there is an entire industry and market developing around family planning, where pre-implantation genetic diagnosis and screening and non-invasive prenatal testing are informing family planning choices for families who are considering having children. And we know increasingly, especially in the consumer space, that genomics is starting to inform lifestyle choices, the way that people live their lives, the food choices, and the activities that they take on. So it's incredibly important for us to continue to provide and drive technologies to the market to help us understand more about how the genome affects us. Our mission at Illumina is to improve human health by unlocking the power of the genome. And that, in and of itself, is an incredibly powerful mission for us to rally around as an organization. And I can tell you, it is north for us at the organization. This is what drives us. It's what gets us to work day after day. It is something that helps us overcome the challenges that we face on a day-to-day basis. It's incredibly inspirational to understand that as an organization, we have such a lofty mission. But there are a number of factors, a number of things that have happened over the years, both from a scientific standpoint, from a technology standpoint, but also from a public policy and from a public program standpoint that have paved the way to where we are today. And so I want to step through some of those for you. Back in 2004, Illumina launched what at the time was a cutting-edge product. It was a microarray that enabled interrogation of 1,536 single nucleotide polymorphisms at once for 96 samples. And that eclipsed the standard at the time, which was a product that allowed interrogation of a dozen or so, perhaps even as little as 3 SNPs at a time. Over the next couple years, the technology really began to move very quickly, both by us and others in the marketplace, where we were able to expand genotyping levels from the 1,500 plex level up to the several hundred thousand level on a per sample basis. And that enabled initiatives like the International HapMap project, which was put into place to basically understand trends in genetic variation across populations, which at the time people believed would be instrumental to understanding more about how to influence health outcomes in the future, but also fundamental to who we are. We also began to see programs like the Cancer Genome Atlas take foothold, where essentially they wanted to understand the molecular basis of cancer in more depth. In 2006, at the end of 2006, the beginning of 2007, Illumina acquired Solexa. And that really started, from our standpoint, our path to becoming a sequencing company. Importantly, though, we weren't the first next-generation sequencing company in the market. That was 454. They launched that technology at the end of 2006. And actually, that technology was used to sequence James Watson here at 7x fold just a couple years later for about $2 million. Around the same time, we began to see other public policy things taking place. So for example, based on some of the work that came out of the Cancer Genome Atlas project and other key opinion leaders, the FDA began to evaluate products like Coumadin, which is a blood thinner that's on the market, and they revised their label claims to state that physicians should start to consider a patient's genetic makeup when deciding on dosage for that particular drug. In 2007, the first Han Chinese genome was published in Nature, heralded in the publication in Nature. And we began to see things like the microbiome project being kicked off, where people were trying to understand, from a genetic standpoint, the influence of microbes on human health. We started to see legislation get passed. George W. Bush, our president at the time, signed into law some legislation that essentially set regulations around anti-discrimination for people's genetic information. And the International Cancer Genome Consortium was launched as well. By 2010, we had introduced technology which, whereas in 2007, it took 3 days to generate about a gigabase of sequence, in 2010, it took less than a day to generate about 200 gigabases of sequencing data. And that began to really open up many clinical applications. So for instance, Nicholas Volkler here was the first child, we believe, that was saved by sequencing. He had a rare, what we believed a rare genetic disease. A disease loci was located, and his treatment path was changed as a result of understanding the genetic basis for his disease. We had another example of a patient with a very severe form of leukemia, and understanding the genetic basis of that. It was a unique gene fusion, changed the course of that therapy, and enabled that person to have a much better health outcome. By 2012 and 2013, we started to see next-generation sequencing labs being set up right next to neonatal NICU units, where children who had unknown disease states, the physicians thought, let's give a shot, let's do whole genome sequencing, and let's see if we can start to get diagnoses for what's going on to either inform the family about what the potential outcome or the lifespan of that child would be, or to potentially find a cure. By 2013, we started to see some of the regulatory milestones in the industry. So Illumina was very proud to actually have the first FDA-cleared next-generation sequencing instrument in the MiSeq Dx bring to market. And we've begun to CE mark additional products in the European space for non-invasive prenatal testing. We've also seen Illumina spin out companies like Grail and Helix, which are working on liquid biopsy and consumer genomics, respectively. Today, in the United States, 80% of high-risk pregnancies are now approved for reimbursement for non-invasive prenatal testing, which is a next-generation sequencing-based test to basically look for fetal aneuploidies like Down syndrome to help inform family planning decisions. And we've launched the NovaSeq just in the past year, which is going to set us up for the future in terms of the next set of breakthroughs. Illumina is a global organization. We have over 20 offices around the world. Our headquarters are in San Diego, California, but you can see from here that we have commercial and manufacturing presences on at least 3 major continents, and our commercial presence really spans all of the major population centers in the globe. And if I just overlay some data from BaseSpace, which is a tool that is used both as a marketplace for genomic analysis applications, but also as a way for Illumina to understand trends in utilization across the globe. You can see where the patterns in production scale and desktop sequencing are. And the blue actually helps you kind of get an understanding of where Amazon has their cloud-based infrastructure, which BaseSpace relies on. We use this information to understand generally how our products are performing in the market, but we also use it to understand where we have emerging trends in terms of utilization and where we need to deploy resources to help customers be successful. Illumina is a pretty unique place, I have to say. As Alexandria stated, I started in 2006 before we were a sequencing company and started in tech support. And today I work in clinical genomics product development, which is fantastic. And I've had tremendous opportunities at the organization, in large part because of how the organization is run and the values that we have as an organization. We're scientists, we're engineers, we're finance professionals, we are legal professionals. We have people who focus on quality. We have manufacturing and supply chain professionals. These are all the people that have to come together to make a company like Illumina as successful as it is. Our culture is of paramount importance. So right next to the mission, I would say culture is really how we identify, and it's something that's very precious, and it's something that we protect. We're very proud of it. Our values as an organization, innovation is in our DNA. We move fast and embrace change. We are relentless in the creation of great products. We believe in deep collaboration within the company as well as with our customers, and we're open. It's these values and this culture that help us understand who we want to hire into the organization, who we want to promote and provide opportunities to. It's the values that actually help drive the way we interact with our customers and our business partners. It guides the way that we make decisions within the company about where we're going to invest. It's a tool that we use to basically help us run the organization and to work with each other. And it's something that is, I believe, critical to Illumina's success today. The other thing that I'm really proud of as a member of the Illumina community is Illumina's commitment to giving back in the communities where we operate and where we work, right? Whether that's in HQ or whether it's in Singapore or Eindhoven or in the UK. We have a number of programs that we've launched to help, in Illumina's unique way, give back. Leveraging our strength in genomics, leveraging our strength in science, technology, engineering, and math, and the sciences. So we partner with local schools to give kids an opportunity to come to our campuses and learn more about genomics. We partner with teachers to help give them tools so that they can teach kids at a younger age about genomics as well. We have internship programs where we seek to bring the best and the brightest from around the world into Illumina to give them an opportunity to learn about the business. One of the programs that we have is called iHope. It is a program where we donate genomes to families who are in need. That is run through our CLIA lab services. We also provide funding to employees who want to reach out and organize in the community to help with philanthropic causes. And so it's an important part also of Illumina's values, right? That not only do we recognize that we're a leader in the industry, we realize that we equally have to be leaders in the communities that we live and work as well. It's also good business to help people find new businesses. So Illumina has an accelerator program to help drive genomic startups. We are on our 9th cycle of Illumina accelerators. We typically have anywhere from 3 to 4 people, 3 to 4 groups per class. Illumina provides the capital equipment, the sequencing reagents, the space, and access to experts within the company to help these startup organizations gain additional funding. Illumina does maintain a stake in those organizations once they leave. Some of those businesses have become very successful. But it's another way that Illumina is trying to drive the markets and to encourage innovation. This is a great chart. This is actually from the NHGRI. And what it is a chart that basically shows the cost of sequencing a genome plotted against Moore's law, which is a construct used in the microprocessor industry to essentially predict the pace of compute power versus cost over time. And you can see that right around this 2007, 2008 timeframe, as the Illumina and Solexa acquisition came together, we saw this precipitous drop in the cost of sequencing, where you can actually see today we've reduced it from a genome costing nearly $10 million in the 2006, 2007 range to just around $1,000 today. And the reason that's important is severalfold. As I pointed out, the Human Genome Project was completed in 2003 at a cost of about $3 billion. You're not going to run too many $3 billion genomes, so obviously there was a need there to reduce the cost of that. The first individual genome was completed in 2006 on capillary sequencers for about $20 million. We got James Watson sequenced for about $2 million in 2007. And just a short while later, the first 30x genome, look at that drop in terms of cost, a 30x genome a year later at $200,000. And the progression has continued. And this opens up new applications. It has created entire new areas of science and research. And so it's an incredibly potent reminder to us that this trend is going to continue to enable science well beyond the capability of Illumina. We consider ourselves a tools provider and an enabler. This is going to enable tremendous science over the next couple of years. But it's not all about just super high-powered sequencers. We actually do have a full portfolio, anything from the NovaSeq 6000, which is really ideal for population-level sequencing. We have the NextSeqs and the MySeqs, which are really desktop solutions, very flexible, allowing for applications that aren't as data-intensive. And down here at the low end of the portfolio, we have the iSeq 100, which is really our attempt to deliver a system and a technology to market that's accessible to almost anyone with a price tag of around $20,000 and a per-run cost that's very manageable. It's also just not about sequencers, right? We have done a pretty good job of making the sequencing workflow very user-friendly. But we understand that that's not the end-all be-all. You actually have to create a way for people to prepare libraries and streamline so that the wonderful applications that all of you are working on are possible. And so we have invested a tremendous amount over the last couple years in simplifying our library prep, simplifying the process of developing new custom content to answer all sorts of biological questions, and continuing to innovate, of course, on the sequencing side. But obviously the next frontier for us, right? So one of the stats that I actually like to talk about is in the third quarter of this year, in 2018, Illumina shipped more sequencing capacity than we did in the entire year of 2016. That creates a tremendous information and analytics bottleneck that the industry, together with us, is going to have to solve for. So these integrated workflows are incredibly important for continued success and democratization of sequencing. It's pretty humbling to understand that we're responsible for the vast majority of the sequencing data that's been generated over the last couple years. Looking at over 100,000 publications with an install base across the world of about 11,000 instruments. And so, again, Illumina recognizes that we're both a leader from a technology standpoint. That puts an obligation on us to continue to innovate the technologies and drive down the costs so we can continue to increase access. I've talked about sequencing, right? Accessibility of the technology. But let's talk about some of the application areas that have really taken off as a result of dropping the cost and improving the accessibility and the usability of this technology. In reproductive health, we have the pre-implantation diagnosis and screening technologies along with non-invasive prenatal testing. If you're not familiar with that, essentially the concept is that placental DNAs slough off into the bloodstream due to apoptosis, and you can do a simple blood draw from a mother, and with a certain fetal fraction available of fetal DNA in the blood, you can actually interrogate the blood for aneuploidies, and that helps people do family planning. In oncology, we've announced some partnerships recently. We facilitate a lot of translational research, but importantly, we have programs in the works right now to work with Bristol Myers Squibb and Loxo Oncology to improve therapy selection, especially in the immuno-oncology space. Population sequencing, I'm going to talk a little bit more about that on the next slide. Of course, we have the research. The advances that we've seen in complex diseases like premature myocardial infarction is fantastic. In the consumer space, the growth that we've seen of our customers Ancestry.com and 23andMe and Helix has been incredible. Infectious disease, I'll have a story on that in a little bit. We recently spun out a company called Verigen out of Illumina that focuses on forensics using the MySeq platform. The amount of work that we do in the ag industry is staggering. Genetic health post-birth, so ailments like cystic fibrosis and other elements of other diseases with a genetic background we're involved in supporting. And of course, we have our collaborations in biopharma as well. So let's talk about precision medicine, because that is a very hot topic. And it is one of the things that we see as a potential game changer for influencing the way health systems and at the private level or at the country level approach medicine. Just a couple years ago, the White House announced a $215 million investment to help drive precision medicine here in the US. About 90% of that $215 million is going into developing this 1 million person cohort with the NIH and the NCI. The NIH is going to handle recruitment and allocation of funds for sequencing. The NCI is going to handle the developments around cancer drug development that come out of that work. And even the FDA is involved with getting money to help put in place databases that are going to support any regulatory outcomes that come out of that work. And you've seen that get some traction here in the news just recently. China also has a very large precision medicine initiative that's getting going, $10 billion over 15 years with 2 million people. A smaller percentage of their population, but still a very potent investment here. They're focused on rare and undiagnosed genetic disease that have a somewhat elevated frequency, general precision medicine, screening of the population, very similar to the types of things that we've seen Genome England work on. So the 100,000 Genomes Project was launched a couple years ago. We've got about 90,000 of those genomes done. Genome England, because of the success that they've seen and the possibilities that they've seen as part of that program, just announced that the next version of the 100K Genome Project is going to be a 5 million genome project. And so they're gearing up to get the funding together for that. And France has set aside almost $1 trillion to set up the infrastructure to sequence about 235 genomes per year. So tremendous, tremendous opportunity and tremendous growth in this particular area of our business. So I've talked about, our mission, and I've talked about our culture and our values. Those are things that drive us. The technology is incredibly exciting. That also drives us. The success of our business breeds more success. But I'll say that the last thing that is probably really critical in us really connecting with the impact that we're having out there in the world is getting a chance to hear some of the stories about the people's lives, the individuals' lives who we change. And so I want to tell you a little bit about Marin. So Marin went in, she was 39 years old when she was pregnant, and she decided to go in and have non-invasive prenatal testing because she was at a high-risk age. And when the results from the non-invasive prenatal, the NIPT came back, the results were a little confusing. And this happens sometimes. There's natural biological reasons why you don't get a clear-cut answer from an NIPT assay because you're essentially interrogating DNA from placental tissue that is sloughed off and circulating in the mother's blood. And so for those of you who know a little bit about fetal morphology, you can have things like placental mosaicism and stuff that can make a result not clear-cut. That's why we have, it's a screen. Our test is a screen. And people are referred for follow-on diagnostic tests, typically in amniocentesis. That result came back and suggested that the baby was fine. But the results of the service provider who was offering that screen, the results were concerning enough that they felt that they needed to do some follow-up analysis with Marin. And come to find out, after follow-on workup, she was diagnosed with anal cancer. So our test that was targeted at evaluating fetal aneuploidy was actually picking up aneuploidies as a result of copy number variation resulting from actual apoptosis of cancer cells that were currently active. As a result of this, Marin's oncologist was able to get her into a treatment program, and today she is enjoying time with her daughter. Right? That could have been a very different outcome had the technology not been available. Stories like that are very, very moving for us at the organization. I'll give you one more story. This is Joshua. So Joshua was, at the time of this event, he 14-year-old boy, but he had severe combined immunodeficiency, or SCID, as a baby. His family worked through that, but at 14, they had just come back from a trip to Puerto Rico, and he was having really bad headaches, persistent fevers, and that started to get worse. And because of where he had been, and because he had meningitis-like symptoms, the physician treating him at the time put him on immunosuppressants, and he wasn't getting any better. Luckily, at the medical center where he was being treated, they had access to a MySeq, and they were able to pull samples, and he was diagnosed with a bacterial infection, but he was being treated with an immunosuppressant. So they immediately stopped treating him with immunosuppressants, put him on some antibiotics, and he was better within a couple days. Right? Totally opportunistic, basically luck. Patients showing up at facilities with really smart physicians who have access to technology. In many cases, serendipity, that people gain access to technologies like this. But that can't be the case. We have to continue to develop this technology in a way to get through the clinical evidence collection to deliver solutions like this to more of the market so that we can save more people like Joshua and Marin and her child as well. So in summary, at the company, we feel like we have a very inspiring mission. We are bound together by our culture and our values. We are excited and honored to have this technology that we can continue to innovate and develop. And we do believe, right, that we have the opportunity to reimagine the future. And this is a quote by our CEO that talks about the DNA revolution that's going on today and how honored we are to be a part of that, to continue to transform our ability to understand the impact of the genome that it has on our lives and to ultimately transform human health. With that, I'd like to thank you for your time, and I'll take any questions that you have. No questions, not even on how can I get a discount on a sequencer? That's a really good question. So a little bit on product. So in 2017, we launched the NovaSeq platform, and at that time, our CEO announced that we had essentially launched the system architecture that would eventually enable the $100 genome. At the time, we had the high-seq X system on the market, which all-in loaded costs with depreciation and staff included, we felt could deliver a $1,000 genome at a system at scale. So what is it going to actually take for us to get to a $100 genome? We need to continue to innovate on the speed and the stability of the reagents that support that. A big part of it is actually compute cost as well, because all-in cost needs to be considered, and that's a huge factor today of cost. And so we're excited about bringing the technology forward and crossing those technological hurdles to deliver the $100 genome. And at the same time, I know that there are probably parts of the world where a $100 genome still doesn't meet the mark to drive the ability and access that we may need. And in other parts of the world today, so for instance, the Center for Medicare Services just approved reimbursement for clinical whole genome sequencing in particular contexts with patients with cancer at $5,000 per genome, which is probably a very realistic price or reimbursement level given the amount of infrastructure that people have to support the program itself, the informatics, the management of the patient information, et cetera. But yeah, we see it as both an obligation and an opportunity to continue to drive that down, and I think we'll see that over the next 5 to 10 years. Question?
Yes, I'm going to ask you a hard question.
Okay.
The map you showed had Africa almost blank.
I'm sorry?
Africa was almost blank on it. What is Illumina doing about this?
That ties in a little bit to what I was talking about in my previous comments, Najib. So thank you for that question. Africa is almost black, and I will say let's just be clear that there's a little bit of a confirmation bias in the base space data. We know that the vast majority of our research customers will actually connect to base space. And so we are able to actually get confirmation that the system is up and it's running. We know, because of information security concerns, that large proportions of our clinical customers, those who are focused on clinical testing, actually run their systems offline. And so we know we don't have a complete picture there. But we also have infrastructure issues in Africa, right? And so even if we had a price point today, using base space as a proxy wouldn't necessarily inform us. But those are kind of subsidiary, kind of to the side of what the real meaning of your question, which is how do we advance the technology to a point where the supply chains and our ability to get into different parts of the world is at that next level. And I can tell you, I can't get into too much detail, but working on thermostable reagents, reducing the footprint of our sequencers, looking at other programs like the iSeq and how that platform needs to evolve to enable portability of the systems at price points which are more manageable is a really high priority for the organization. And I think the innovations in the core technology over the next 5 to 10 years will make placements, field placements, in countries like Africa and Russia and other countries where we don't have the infrastructure available today possible. But they won't necessarily show up on base space if they're not connected to the cloud. So thank you for that. Yep. So I think a couple things. One, I think it's important for institutions to understand that for students who don't want to go down the Ph.D. route, that for those students who are expressing interest in an industry path, it's important for them to develop marketable skills. And so they have to develop skill sets that can be immediately used at the research associate or associate scientist level in industry. So I think to the extent that institutions like this can support that work, that'll be really good for the students. And companies like Illumina have a need for people who are really bright, who are really interested in coming in and contributing at that level. But science isn't the only way in. We have also a number of people who with business degrees or business and biology double majors who perhaps go into the business side of Illumina and do very well for themselves. For any students who are considering a PhD in the life sciences, I would say go for it, even if you know that you don't eventually want to end up in academia. And the reason for that is that the skills that you gather in undergraduate in terms of problem solving that you build on in a PhD, the abstract problem solving, those all apply to almost any career path, frankly, that I think you might want to choose or that presents itself to you. And so I know that there are people who've had different experiences with landing a job after graduate school or undergraduate. For undergraduates, it's really about making sure that you have the marketable skills and lining up the internships and the curriculum that are going to get you those skills. And for the graduate students, good people with excellent problem-solving skills who can persevere through failure will do very well in almost any career path that they choose. So that's how I would answer that. Thank you.